This week we're going to be dealing with climate change and sustainability, a great global challenge that many of those who sign up for this class already know quite a bit about, others perhaps less so. You'll have to bear with me as if you've come to this week with a lot of expertise, you may find some of these things rather basic, but we have a class of tens of thousands of students, and so we have to make sure that we're getting some of the basic facts out, trying to understand also why we should care about these facts, and then in the end, once again, a big challenge, what we can do in the face of global climate change. So let's start off with some of the basic facts. Climate science has made enormous strides in recent decades. We understand patterns in the climate much better than we did even 25, 30 years ago. And now there is an enormous body of evidence that shows that the planet is getting warmer, and that human activity has contributed significantly to the warming of the planet. This, of course, was controversial for a while. And I guess part of the reasons it's controversial is because the science is complex. It's based on big data and computer modeling that is not easy to grasp. It's not intuitive. I think it's also controversial because it calls to us to change our behavior in ways that will have very serious economic consequences for lots of people in the industrial and in the developing world. Different kinds of consequences for those two regions. But it's very clear now that the massive consensus among scientists around the world is that the planet is getting warmer and that human activities, since industrialization in particular, are contributing greatly to the warming of the planet. The National Academy of Sciences in the United States and climatologists all over the world agree on this. The human factor in climate change is really beyond scientific dispute, and it comes through mostly the burning of greenhouse or the release of greenhouse gases due to the burning of fossil fuels. You know, very, very clear. I stress this because in my country, in the United States, there are still politicians who want to deny this. There are still industrialists who want to deny this, that it's the burning of fossil fuels that is a great contributor to climate change. And the scientists no longer have doubts about this, and you can, if you try to find somebody who says I don't believe it, yeah, that's great. But there are thousands of scientists now who understand the dynamic and who have prudently come to conclusions about how much warming we can expect and what that warming will do to climate patterns and to our way of life in different parts of the world. Now, the projections for warming are may not sound as frightening as you think. We believe that between 1.4 and 6.4 degrees Celsius is the range of the increase over the coming century. Between 1.4 degrees Celsius and 6.4 degrees Celsius. That's a very large range, right? I mean, that's a significant range, and it's on top of an increase since the last century of 0.8% Celsius. We have an animated map that allows you to see the results of these changes, and I hope that putting it in graphic form makes it even more clear where these trends are taking place and over what periods of time. In Elizabeth Kolbert's book, Field Notes from a Catastrophe, she quotes a climate researcher as saying, "This is not something that's dramatic now. That's why people don't really react. But if you can convey the message," he writes, this is the climate scientist, "that it will be dramatic for our children and our grandchildren, the risk is too big not to care." And I think that's the message, really. We have the risk The risks are too big not to care. He went on to say, right now, it's already 5 minutes past midnight. In other words, we have gotten so close to the edge of catastrophe. We are in a catastrophe that's unrolling. And yet, the actions that governments and industry are taking seem inadequate given the scale of the problem. Now, why is that? I mean, that's that's the puzzling part of this, right? Is that we hear about the massive scale of the problem, and yet we hear about these long negotiations that end in tepid resolutions about changing our behavior. We continue to dump tons and tons of carbon into the atmosphere at increasing rates in many parts of the world. And we have the science to develop renewable energy, although we don't have it at the scale or with the economic framework that's necessary for massive use. But still, the reaction seems muted compared to the scale of the problem. And one of the reasons people have speculated that that's the case is that we humans have a real hard time thinking long term. You know, we like gratification. We like to get something done and then it's done and we feel good about it. You know, many of you will know this experiment about delayed gratification where the toddler is looking at a marshmallow and is told that if he doesn't eat that marshmallow for 5 minutes, he's going to get more stuff, right? And a lot of kids just, as soon as the experimenter not there, eat that marshmallow. And some of them can wait. Some of them do things to wait. They go like this. They don't look at the marshmallow. They do all these things so that they can think of the long term, project into the future. And scientists have studied these kids over many years, and they find the ones who could really wait are the ones who do better on their tests, who seem to have more success in their lives. And so the speculation is if you can think in the long term, if you can delay gratification, lots of good things will come in the wake of that willingness to delay gratification. But the temptation to grab the gratification right away is strong. We want to employ more people tomorrow. So you want a quick industrialization. We want cheaper gas. We want to be able to cool our houses in the summer more efficiently. All these things we can do right now. We can do right now. The long-term consequence of doing those things right now, scientists understand, but the rest of us seem to be just focused on the near term. And neuroscientists today say that that's because our brains were built for shorter-term responsiveness. And it's much harder to think about the world that our grandchildren will inherit than it is to think about wanting to set your thermostat higher in the winter and lower in the summer because that feels good right away. If we continue to aim at feeling good right away, scientists have shown us we will destroy the planet. We will destroy the conditions for life as we know it. That's very dire. And yet there are ways in which right now we can change the trajectory of our impact on climate change. There are 6 major things that I want to talk about that we know will happen as a result of climate change. Rising sea levels, increase in rainfall and intense rainfalls in many parts of the world, a decrease in snow and ice cover, increase in heat waves, a change in the growing seasons. Different parts of the world will experience this differently. And then acidification of oceans, the growing acid levels in the ocean. There are lots of other things one could talk about, but I want to talk mostly about these 6 areas. Now, I should say that many things, it's complicated to make predictions in these areas because this is a very dynamic system and with many, many variables. And changing some of those variables will change all of the outputs. Despite that complexity, it is clear that the Earth's future climate will be unlike the climate and that we have had for centuries. And that over the last 10,000 years, humans and other species and other ecosystems have gotten used to a certain climate, and we thrive in a certain climate. And that will change that is changing very dramatically. Even in the 19th century, some economists and scientists recognized that industrialization was contributing to climate change, that dumping carbon into the atmosphere had to have some impact on the weather patterns, because carbon interacts with other elements in the atmosphere, and that carbon can be reabsorbed in the earth by vegetation, for example. But as we put more and more carbon into the atmosphere, even in the 19th century, economists speculated and scientists speculated that we were putting more into the atmosphere than the earth could reabsorb, and that there would be consequences for that. So we're here today to talk with two of my colleagues at Wesleyan, and we're going to be talking about climate change. You've met them before. These are colleagues from the College of the Environment at Wesleyan, and climate change is obviously one of the largest subjects of public concern, of scientific concern, and our students will be reading some short, basic papers on the changes in the climate and responsibility of humans for those changes. And I thought I'd start off by just asking each of you to say just a few words about what are the most important facts that you think people should know about climate change today. I mean, what, as you think about it as citizens, as researchers in this field, what do you think that everybody should know about climate change?
So, climate change is a reality, and I want you to know out there that humans are largely responsible for the acceleration in climate change that's happening because of our daily lives, and this is being accentuated primarily by people in relatively rich countries, for example, in the United States and now in China and whatnot. And the key thing that we should know is that what we are coming to a threshold soon, and what we choose as a world to do and will really determine the prosperity of people on the entire planet within the next 50 to 100 years.
I work in Peru with schools as well as native communities, and we are doing these communal gardens with the schools. And we do this to teach ecological literacy, which is very low, abysmally low. And to motivate the teachers and the administrators, my colleague Pramod and I give a workshop, and we tell them, now we are at 400 parts per million.
Yes.
When we reach 600 parts per million, something cataclysmic is supposed to happen. And if we continue at the rate we are going and don't do anything, this is going to happen, as you say, within 100 years, less than 100 years. So it is absolutely our responsibility to teach the new generation.
Yes.
And of course, this kind of agriculture sequesters 3 times, by not cutting the trees, by not burning them, and by putting biochar in the soil, which keeps sequestering CO2.
Yes.
So, it is, we try to not scare them,
Right.
keep that balance, not too scary, but really, and I feel it intensely, I feel that we need to, and that is in fact why I do what I do, because otherwise I would be despairing. So direct action, and I love what Barry said, and this agriculture is both for food sovereignty and health, but it's also for climate change.
Yes.
I mean, the great expert on this soil and biochar is at Cornell, Johannes Lehmann, and he has created the International Biochar Initiative. And according to him, if all agriculture were this kind of agriculture with biochar, we would solve our climate change issue in a few years. Of course, the obstacles to that are staggering, but from my tiny experiment and from the studies of soil scientists and other scientists, this kind of soil is much more productive. In fact, the experiment that he did with one of his graduate students, he said it's 800% more productive and it's permanent. So you can grow more food without any agrochemicals, without petroleum products, and it's healthy, and you are sequestering CO2. So it's my passion. I push it whenever I can. And this is something, and we're trying to do it here, even though I got bad news from Barry recently about the little experiment with biochar they did.
Yeah, and that doesn't prove anything.
Tell us a little bit, because some of us won't know enough about biochar.
This soil was discovered fairly recently by archaeologists in the whole Amazon basin, the low Amazon, the high Amazon. And it's been studied. The one who studied the soil is Johannes Lehmann, a soil scientist. He was in Manaus for years. Now he's at Cornell, has his lab. And what gives it, it's called Terra Preta do Índio in Brazil, which means black earth of the Indians. And it's still fertile today. It's sold as potting soil.
I see.
And it hasn't been touched for 500 years because 9 out of 10 Amerindians died after the Spaniards arrived, so the forest took over. But they were great cities. It was a very populous, complex civilization that just vanished. But the soils haven't vanished, and the local people know how to use it and continue to use it. So it's really an extraordinary. And the oldest ones are 8,000 years old. The black color is given by biochar. Now, biochar is a particular kind of charcoal which is carbonized without oxygen. And it produces this biochar. The name is very recent. I think it was given in 2004 or 2005. And ideally you use agricultural residue. That's what we do to make biochar. And it is porous, so it can retain nutrients. The nutrients stick to it, and the torrential rains don't wash it out, and it sequesters CO2. So I am taking it on the word and the work of the scientists. I have not had this scientifically legitimized in what I do. We just know that on degraded land we have bumper crops where nothing grew. So, but I don't know about, is it sequestering CO2? I just know that we need it to not continue cutting the forest and burning it, that sense. So in those two things we are. But whether additionally they're sequestering, I take it on the word of the scientists.
The reason it's sequestering is because, as you said, it's the chemical term is pyrrolization. That is, it's formed without oxygen. So actually, none of the carbon leaves into the atmosphere in the formation of this. Now, it doesn't suck carbon out of the atmosphere, but what happens is that when the roots of the plants respire, they actually, just like we do, they give off carbon dioxide, and then it sticks to the to those clay-like soil particles. What many people don't realize, which really contributes a lot to climate change, is that when people till the earth and turn it over for replanting, huge amounts of soil are released. So, for example, in tropical areas,
carbon is really...
832 metric tons per acre of carbon dioxide is released into the atmosphere. In the temperate zone, on average, like in the United States, it's about in excess of 600 metric tons per acre that's released into the atmosphere, and that comes from both microbial respiration and plant root respiration. So this stuff is able to stick it, and unlike with normal agriculture for biochars, you do not till the soil. You just plant, and then you're returning the excess back into the soil. So the process of formation doesn't release carbon into the atmosphere, and the carbon of root respiration doesn't go. So it has that property. And one thing that's, Frederic has brought up the issue of the relationship of climate change to global temperatures. What I'd like to point out is that if we don't put another molecule of carbon dioxide into the atmosphere today, the Earth will still heat for another 63 years on average, because the carbon dioxide remains in the atmosphere for an average of about 63 years. So even with what we have, the experts like Jim Hansen are convinced that we are committed to about 1.5 degrees of global centigrade of global warming. And we should know that every grain crop that exists, whether it's wheat or maize, barley, etc., for every degree centigrade nighttime temperature that the Earth heats up, there's an approximate diminution in productivity by about 10%. That includes rice. So as the Earth heats up, the current plants that we have will be decreasing their productivity, and this has been taking place for quite a while.
So the question of the effects on people in different parts of the world is one that I know policymakers and citizens and corporations are much concerned with. And I'd like to talk a little bit, I guess, about the differential effects of climate change. I mean, it is a global phenomenon. Everyone will be affected somehow. But, you hear people joking about it, when the weather's nice, and they say, oh, I like this climate change. It's warmer in October. And I guess there will be, I hate to put it so crudely, but winners and losers, or people who will be more vulnerable and less vulnerable. And after, maybe we can just talk about that.